Okay, this is our proof by contradiction question. It says that given that A is rational and B is irrational, A minus B is irrational. So we're going to assume the contradiction of that. So we're going to assume that given that A is rational and B is irrational, we are going to assume that A minus B is rational and hope along the lines somewhere that we get some sort of contradiction. Now, if A is rational, then it can be written as a fraction. Say m over n, where m and n don't simplify any further. So m and n have been simplified as much as they can. This fraction has been cancelled down to its simplest form. B is irrational, so we can't do anything like that with B. But what we can do is, because we're assuming that A minus B is rational, that can be also written as a fraction, say P over Q. We've already said that A can be written as m over n, so m over n minus B must be able to be written as P over Q. Now, if we make B the subject, we're going to get m over n minus P over Q. And we can write that as a single fraction. If we multiply the left fraction by Q and the right fraction by n, top and bottom, then we get that B is equal to mq minus np over nq. But that's a fraction. That's a fraction with a rational top and bottom, which isn't allowed if B is irrational. So this is rational. But B isn't rational. Which means we've come to a contradiction. So to conclude, A minus B must be irrational if B is irrational.